Good morning, everyone. A warm welcome to everyone to RSAConference 2023. So today's session is going to be for the life of an image, evaluation of vulnerabilities in popular containers. And we have today our speaker, Ayse, who is a Senior Director, Strategic Insights and Analytics. Welcome, Ayse.
Thank you.
So I hand over the mic to Ayse and let her take over.
Thank you. Thank you so much. Let's do a quick sound check. Is the quality okay? Can you hear me well? The back of the room? Perfect. A little higher. Is this better? I can do higher. So, have you ever felt like you're on a high-speed train, you're taking snapshots of the scenery, and every time you think you have captured it, the moment that you look at it, the environment has changed drastically. That's how I have been feeling as a data scientist who has spent the last 15 years of her career in the intersection of AI and cybersecurity, of InfoSec and data analytics, especially in the last 8 months, and definitely in the last 5 months since GPT 3.4. And don't get me wrong, I am very familiar with technologies with a hockey stick growth curve. I actually studied emerging technologies and technological forecasting at MIT. And I'm also not only familiar with AI from a quantitative lens as a data scientist, but I'm also an AI ethics advisory board member at Northeastern University. So I've been thinking a lot about these things for this last several years. But in my career, I have never seen an advanced tech that's born in the West Coast show up in rural India, in Turkey, in a matter of months. The rate of diffusion is simply breathtaking. And at Slim.AI, my startup, we are thinking a lot about the juncture, the meeting point of AI and cybersecurity all the time, especially as it relates to the, looks like we are missing a slide here, especially as it relates to the container tech, how containers are evolving over time with this new landscape. So at Slim, we scan hundreds of thousands, millions of containers on a regular basis. We're obsessed with container security and container optimization. And in the last 18 months, we've been publishing these reports, putting a magnifying lens on the top publicly available containers. And my research team is deconstructing and observing these publicly available containers to understand what makes them production ready and developer friendly. So 18 months ago, end of 2021, we published the first report, and it was a first look into the impact of container size on scan times. We were actually interested in understanding the size and how new vulnerabilities are being introduced into the system, but we needed trend data for that, which we actually got over time. And we looked into package complexity, vulnerability counts, and severities in these containers. Fast forward to 2022, we published a sequel to this report, this time focusing on the delta between 2021 and 2022. And we actually added a survey on top of this, ran a global randomized study, asking questions to developers and DevOps engineers to truly understand the impact on our people. In the last 6 months or so, we are doing a lot. We are taking a deeper research approach. We are looking into continuous tracking and daily challenges and damage inflicted to our defenses by the new vulnerabilities introduced into these systems. And what we are finding is a constant influx of and backlog of vulnerabilities into these systems. We are seeing the dynamics between rupture and repair, how these vulnerabilities are being resolved. And we are also seeing things that I call packets of density, packages with lots of vulnerabilities, vulnerabilities that impact tons of packages versus the rest. And finally, I'm seeing something interesting in the data as, I call it the decisions that others make for you, those packages with no fix that seem to be lingering in these publicly available containers. And going forward, and we actually started doing that, our goal is to predict the future state of your containers, learning from the hardening results at scale. So doing this dynamic pre- and post-hardening analysis to quantify the impact of hardening in your containers. But as we travel into the heart of this research, as I synthesize the results for you, I would like us to keep in mind, in the back of our minds, to think about the recent developments in AI, in conversational AI, in Gen AI, and how that affects the container landscape in light of this data. So just to make sure that we're on the same page, this is definitely not a progression, a history of what happened, but this is my take and the type of conversations that we have been having in the last 8 months about Gen AI. So I want to make sure that we're on the same page on that front. So about 8 months ago, when we were discussing conversational AI in my AI ethics advisory board, the main consensus was that it was only a sophisticated version of autocomplete, playing the game, what's the next world? But we were saying, this is very simple, but surprisingly lifelike. But does it even know the difference between right or wrong? Then we started saying, this may disrupt the digital world, maybe even steal Google's crown. In the last couple of months, in the last month that I joined several AI conferences, and I heard people, like Max Hegmark, a physicist, a well-known physicist at MIT, he said, this is an early AGI, an artificial general intelligence with reasoning capacity. And I heard several coders talk about how they are a year away, maybe less, from being 5 to 10x more productive. Before AutoGPT, there was this conversation around how if we build an API to GPT-4, it will become a real agent making decisions for us. And I think we see sparks of that already. And from a philosophical perspective, last month I heard Eric Schmidt say, we need a Descartes or a Kant of AI. Few people can do math and philosophy, engineering and sociology simultaneously on a professional scale, but we need those people now. We are playing with fire when it comes to AI. And Satya Nadella, a more optimistic technologist, he said at Davos, this is an empowering moment for us. We will be doing a lot more with less, but are we ready? Are we ready is the question I think every relevant field needs to ask itself. And I don't think we can answer that question properly if we don't think about how things have been improving in that field. Because what we need to do is to extrapolate into the future with uncapped speed and decent intelligence added into the system. So what happened in the container landscape recently, in the last year and a half? So we published the top public containers report in 2021, end of 2021, as I said. And what we did was we took the top publicly available containers with billions of pools, which this container set actually accounted for 30% of almost all use. And we scanned them using standard open source tools. We use X-ray from Slim Toolkit. We used Sift and Gripe from Encore for SBOMs and vulnerabilities. And the things that we were interested in answering, the questions that we wanted to answer was very simple. Are these containers easy to use? Are they safe and efficient? And will they cause any issues when we ship them into production? So we took these containers, created them into 9 different categories. Some of them are spatial purpose, some of them are general. And in each category, we ran rigorous analysis. And our analysis revealed a complex container landscape that's difficult to secure. There are 3 findings that I would like to highlight today. The first one was about slimming the containers, or actually not slimming, the impact of not slimming the containers on the productivity of CI/CD flows. So what we have seen is, like that chart in the middle that you're seeing there is showing a linear chart between scan times and the sizes of these containers. And it was, that was almost like this perfect correlation with every 500 megabits added into the system, the scans were taking 50 seconds longer. And in a very small environment, a developer pushing this container to production every once in a while, that's one thing, but we know that scale is everything. And at high scale, we knew that this was going to be a problem. But more importantly, we realized that understanding the composure of both general and spatial purpose containers required massive effort. On your right, you're seeing a series of box plot charts, and I know that it is hard to see, so let's zoom in and focus on packages. So we were looking into spatial permissions, licenses, packages in these public containers, and this is a box plot chart of several different categories, from programming languages to base OS, web development. In every category, there are multiple containers. When I looked at this chart, I was quite surprised because I was expecting to see some outliers, certain containers, container categories having a large number of packages. But it looked like even the median numbers, the averages seemed surprisingly high. Category over category. Like there were certain containers with more than 1,000 packages. But the average container had hundreds of packages. And if you think about this, this is just the tip of the iceberg. There are multiple academic studies. I pulled just one from Darmstadt University from 2019. This has obviously changed significantly, but that was our baseline. If you look at the package reach of top 5 packages, it was between 134,000 to 166,000. So if you had these, in a hypothetical scenario, if you had these 5 packages alone, you might have a dependency tree that has 5,000 other packages, and they have their own. So think about this. Like, you have these containers with thousands of packages, and each package may have thousands of dependency trees. That's the complexity that we are talking about. So I wasn't expecting to see that many packages in these containers, but that was the status quo. And the last one from that report that I would like to pull in, and I know there's a lot going on here, but I would like you to take away this. Obviously, this room, security practitioners, know that attack surface is more than a vulnerability count. But when we looked into the vulnerability counts in these containers, there were thousands of vulnerabilities in these containers, in some of them. And even the average was pretty high. But what really surprised me was not the number of vulnerabilities alone, but their distribution. Category over category, it looked like 20% of all vulnerabilities belong to a critical or high severity category. 20%. Let's fast forward to 2022. But this time, we have the benefit of a crisis that we have gone through, Log4Shell. And as an industry, we are a lot more invested in understanding the software composition, not only the principal components of our software, but the second-order effects, their dependency trees. And 2022 has become the year of software supply chain security. So as a team, we wanted to capture how this renewed sense of awareness changed the container landscape, the complexity, the vulnerabilities. Is this making any difference from a quantitative perspective? So end of October, as I said, we published our new report, the sequel to the 2021 report. Before going into the details, I just would like to give you a quick overview of the data that we leveraged in this one. This was significantly larger than the previous one. At this time, we had at our disposal more than 900,000 unique images scanned at our platform, Slim.AI, and we had almost 30,000 container profiles. Even the metadata about these containers, their SBOMs, were more than 77 gigabytes. And we had 12 months of daily scans for these popular containers. So it's a data scientist's dream compared to the first report. So I'm going to synthesize the findings from that report in the next 3 slides. And I know there's a lot going on, but I will walk you through these details and make sure that we have the most important insights from each and every one of them. The first learning that we had was that we have more high and critical vulnerabilities than ever across all categories. So 60% of the top publicly available containers had more vulnerabilities than before, than a year before. And yes, we were remediating incidents, but we were detecting incidents at 4x faster than our remediation rate. And it seemed like in that year of tracking these containers day over day, it looked like the things that we were resolving were mostly low and negligible incidents, and the new incidents that were coming into the system were mostly high severity critical incidents. So end of 2022, the average publicly available container had almost 3,000 vulnerabilities, CVEs in them, 30% of which belonged to a high or critical category, up from 20% last year. And we thought 20% was too high. Let's move on to the next finding. We found that it is not just the CVEs. The component complexity has also risen significantly in the last year. So we found that the average public container had almost 400 packages, and that's the average, about 14% increase from last year. But it wasn't only the packages that were increasing. It is the licenses. The licenses have increased by 2.5x. The layers, 4x, right? These containers were larger in size. They took a lot longer to scan. And even the metadata about these containers, their SBOMs have increased by more than 40%. And we coupled this insight with a global randomized study at its core asking the most important questions. Data is data, but what's the impact on our people? How are developers and DevOps engineers dealing with these riskier, more complex containers? So first of all, we found out there's a disconnect between the top-level executives and the frontline workers. 49% of the executives think that their containers in their companies are slimmed and hardened, but those at the front lines, those people who do the actual work, were reporting significantly lower numbers. 92% of the developers said they would like to learn more about containers, but 88% said it has become significantly hard. It has become very challenging to remove vulnerabilities in the containers that they have. And when we asked if you understand, like how do you understand how slimming, container hardening and slimming works, only 1 in 4 developers said they understand that. And this is just the understanding part. It is not the execution part. And this one still is, especially in light of the data that we're about to look at, is the most concerning to me. In that survey, we realized that the majority said they're using manual processes to slim and harden their containers. So manual processes are the most common way to slim a container in the companies that we asked the question. So I know we talked a lot about multiple things here, but let's level it up. Like if you ask me the most important insights from these two reports, I know we looked into a lot of things. To me, the important piece here is that in that year of observation, closely observing these containers, we realized that of all the publicly available containers that we looked at, 60% had more vulnerabilities in them compared to a year ago. And couple this insight with that 70% number, which is the percent of developers who say their customers are demanding their containers to have 0 vulnerabilities, right? And on top of that, 88%, which we just talked about, admitting that it is getting more challenging to ensure containers to have 0 vulnerabilities, complexity being the #1 contributing factor. The underlying story to me is very obvious. Containers are getting riskier, more vulnerable. Customers are demanding perfection, governments and companies, and developers are feeling the pressure. And using manual processes to tackle this problem, to me, it just says we are nowhere close to bridging the gap. That land of 0 vulnerabilities seemed out of reach. So fast forward to today. Looks like there's a little mix-up with my slides, which we fixed earlier. Sorry about that. I will have to go through a couple slides to make sure that we go through the right flow. Sorry. So in the last 6 months, what we are doing is looking at these vulnerabilities with a closer lens. Not just looking at the total count of vulnerabilities, for example, but day over day, how many new incidents are being introduced to the system, how many of them are being removed, packet changes in these containers, and how those updates affect the vulnerabilities. And right now, I just pulled a racing line chart for node latest, which is one of the best performing containers that we looked at from a vulnerability count perspective. So I can see month over month how many of the incidents are being removed from these systems, how many new vulnerabilities are coming. So the community is working to remove vulnerabilities, that we can tell. New influx of vulnerabilities are being introduced into the system. The existing vulnerabilities from the previous scan seem to be decreasing month over month, and the totals seem to be decreasing about 10% from the starting point. If you look into the details, though, that total number, it had a lot less critical and high incidents, and towards the end of the cycle, we are seeing a significantly more number of vulnerabilities. So it's important to look into not just the totals, as we were focusing on mostly in the first few reports, but right now we are looking at the true nature of this change. So as opposed to node improving a little bit from a totals perspective, today, almost 6 months after the second report, there is not a single category or a distro of containers. So from Ubuntu to Debian to Alpine containers that we looked at, there is not a single category that has fewer packages and vulnerabilities in them. But is this really surprising? To be able to understand the nature of what's going on here, should we take a step back and look at the forest and then get a lot closer to look into the trees in the system? So let's take a step back and think about a CVE and how these vulnerabilities are identified. Typically, the way to find a CVE is you go into a system, a security researcher identifies an issue through vulnerability research. They typically inform the vendor and the manufacturer, and the manufacturer starts evaluating. And if they think that it's a legitimate vulnerability, they develop a mitigation, and they put an identifier to the CVE and put that into a publicly available database. So at its core, it's a very human-centric activity. And looking at the data, I think I can tell this is the case, because I looked into the CVEs discovered over time and how they are changing quarter over quarter in these publicly available databases that we are talking about. And yes, it seemed like we are finding CVEs twice faster compared to 5 years ago. But compared to the influx of new code into our systems, the rate of change is simply nothing. Here is what I mean with that. There are a lot of studies talking about the influx of new code into the system, and this is prior to Gen AI and AI systems coding for us, right? So VP of Security at Encore, Josh Bressers, recently shared a blog post talking about the open source and how it is bigger than we can imagine. He said, looking into the NPM ecosystem, he said, if this rate of change continues, we are going to be adding more than 1 million new packages, NPM packages, to the system per month soon. And this is the baseline that we are talking about. So there are about 2.3 million unique packages, and when you add the versions, we are talking about 32 million, and he's talking about adding 1 million a month. And he said, if we were to conduct a security review on 10,000 open source packages per year, this is already a number that would need thousands of people to accomplish. But even at 10,000 projects a year, it would take more than 3,000 years to get through just NPM at its current size. So I know you might be objecting, maybe there's not that many legitimate, unique packages, and it's maybe just 10% or 15% of these numbers, but we are still talking about very large numbers. And compared to the CVEs that has been discovered in these systems, there seems to be a mismatch. And I would like to talk about that in more detail in a bit, like the way that I'm seeing it in the data. But before, let's talk about what we have in front of us right now. We just entered an era of recursive self-improvement and generative AI that is going to, and already is, reading, producing new code at previously unimaginable speed. And I think a lot of us in this room will agree that there will be a lot more code than ever before. Anyone who can write a prompt can produce code. So it's not your developers in your company, your business stakeholders creating new opportunities for your company, but they might be also creating new security risks for the enterprise. AI agents without the prompts are already creating code with recursive self-improvement. And security researchers, security analysts that I know already started augmenting their work, finding these CVEs much faster at faster rates, and AI helping them find the needle in a haystack faster. But the reverse is true. The opposite is true as well. AI agents are already being leveraged. There has been a lot of new papers in the last couple weeks. I have seen one in Wired about how bad actors are doing the same, basically creating more robust, malicious code using these systems, basically weaponizing AI. But even without this, right, when I look into the packages that we discovered in these publicly available containers, and there are about 55,000 of them, of all the packages that we observed, only 14% had vulnerabilities. And if you look into the popularity of these containers, and the way we have defined it is by looking into how many packages these containers exist, and how many different containers these packages exist, the more popular packages, let's say if a package is shared in 30 different containers, there's a significantly higher likelihood that it has more CVEs. So these popular packages have a lot more eyes on them. But what does it mean for the rest, for the 86% that have 0 vulnerabilities? Because they are not under spotlight, their imperfections are not that obvious. But I'm pretty sure if we had the right resources to look into them, we will find a CVE or two. So if we had an army of security researchers, right, biological and non-biological intelligences, looking at these packages, would we see still the same picture, same number of CVEs? I doubt it. So category over category, from web development containers to programming languages to build tools, the top 1% of packages were explaining 20, 30, 40% of all CVEs in a system. Right? And I actually took these most toxic packages, if you will, and fed it into ChatGPT, trying to understand if there are commonalities. And the thing that it came up with was, these are packages that are in a lot of systems. It actually talked about how some of these are database software, which is more vulnerable than others. And it talked about how there are system libraries and utilities. So the usual suspects are the ones that have the most number of CVEs. Looking at the same data from a different perspective with this visual, I just wanted to showcase with a force-directed graph what the true distribution looked like. So for the containers in the build category, and I have it for every category, and they look very similar, I left out all the packages with 0 vulnerabilities, and then I graphed that package to CVE information graph. Right? The green nodes here are the packages, and the red nodes are the vulnerabilities. And as you can see, there are these central hubs, few packages that explain away most of the vulnerabilities in these containers. And a security admin looking at this can use this information for a priority exercise. So if I were to remove these 2 packages from the system that's shared in my containers, the number of CVEs that I'm going to decrease down is X%. But as a data scientist, I look at this and I say, okay, this seems to be a very heterogeneously distributed system where a lot of the packages are not on the radar. So a package that has 0 vulnerabilities in it, which is going to be the most likely use case for every package, might still be a huge security risk. The fact that it doesn't have a CVE doesn't really make it okay to push it to production if it is not core to my application. So that was the distribution of vulnerabilities. Let's look at our resolution rates, the rupture and repair. So across all categories, and I pulled a few, programming languages, build tools, those high-level categories, what we see is that during the last 6 months that we analyzed these containers day over day, once we detect a vulnerability in these systems, the likelihood that that vulnerability is removed from that system is very low, very, very low. 20% of the incidents that we detected in these systems were resolved in the analysis time frame, the 6 months. And there were certain categories like programming languages, for example, did a better job, where about 34% of the incidents that was captured during this time frame were resolved. But many other categories we're just resolving 10%, 12%, 14% of the incidents in a 6-month time period. And it is not just the low severity, the critical incidents only. So when you look into how these vulnerabilities age in these containers, the average CVE lived 130 days in the system that we looked at. And we looked at these systems for about 195 days. So yes, high and critical severity incidents tend to be removed a little faster, but definitely not fast enough. So you are seeing a B swarm chart here where you can see how many days these CVEs were alive in these systems. And from the most critical to the low severity incidents, you see that a lot of them stayed in these containers forever, for the entirety of this analysis. And I looked at it from different perspectives. This is a distribution that we don't need to go into detail, but telling the same story. These vulnerabilities in these systems are not aging gracefully. One last comment about this dynamic that we are observing. The CVEs that stay in these systems forever, I don't see a hope for these things to be removed anytime sooner, too. And here is the rationale behind that observation. So looking into the Sankey diagram, especially that yellow bands that are talking about the not yet resolved incidents, you will see that a significant percentage of them will not be fixed. They have a status of won't fix. What that means is that the package maintainer said, you know what, this CVE, for one reason or the other, is not going to be fixed in this package going forward. It could be the fact that the package maintainer do not have the capacity to do so. And there are a lot of open source packages out there with a single maintainer. It could be the fact that that CVE is the existential reason for that package, that it's necessary for that package. There might be justifiable and unjustifiable reasons for it. But the package manager basically said, the maintainer said, we won't fix a majority of these CVEs that we have introduced into your system. And as the container maintainer, it could be a community like Node, you accept that risk. You say, OK, you made that decision, and I accept that risk, and I'm going to harbor the CVE in my environment, which to me is a very uncomfortable position to be at. So even without the massive flow of new code and newly detected CVEs in our containers with AI systems, it seems like we are having a significantly hard time coping with these issues. And I have heard a lot of container experts talking about how we are living in the stone ages of container management. The growth has outpaced our capacity to manage these containers at an order of magnitude, by orders of magnitude. And don't get me wrong, I do think that containers are simply great. They are agile, fast, efficient. But it looks like there is a lot of opportunity for innovation when it comes to container management. And especially when we look into the future, this vast and varied and complex world that containers have given us, they provide a ton of opportunities to the developers to scale fast at previously unimaginable speeds. But they seem to be introducing lots of risks into the ecosystem. And especially when we look into the manual processes to remove the vulnerabilities from these systems, I do become very concerned about our progress in light of the new code that is going to be introduced into these systems. To me, and at Slim we believe this, it is more important than ever to automate and optimize these containers at scale. We believe you need to know what's inside your containers and ship only what you need to production. Containers cannot be a black box. We need to integrate automated vulnerability remediation tools to our CI/CD pipelines and optimize our images, remove vulnerabilities, and reduce supply chain risk. And it can't be with the human-in-the-loop systems that we have right now. And we need to remove excess and unused code from our containers. So if a package doesn't have any CVEs, it is not OK to ship that package, especially in light of what we just learned today, right? It increases your attack surface and the likelihood that we will be finding more vulnerabilities in these packages with AI systems is pretty high. I am cautiously optimistic when it comes to generative AI and its intersection with container security, cybersecurity in general. But I do think that this is a time when we need to be very deliberate, very intentional about our next steps. I believe this year's RSA team, Stronger Together, is the only path forward. Thank you so much for listening. I would love to see some questions. Thank you. Yes.
You had earlier in your presentation a slide you labeled Figure 5. And looking at that slide, the thing that strikes me is not only the vulnerabilities, but the thing I would like you to discuss a little further is the interrelationships between the vulnerabilities within a given container. I mean, you have some that are operating systems, some that are applications, some that are databases, and so on. But I want to hear a little more about what you've seen in your research as far as potentially the interrelationships between the vulnerabilities as a step forward as to how to optimize, get rid of waste, and all that sort of thing.
So the question is to understand the type of container that we look at and how that affects the number of vulnerabilities. The interrelationships. So it's definitely, like if it is a from scratch operating system level container, right, we see very little vulnerabilities. And data science containers, for example, have tons of packages in them, thousands usually, and the vulnerabilities are huge. So there's that size to vulnerability correlation, and that is also a byproduct of the type of container that we are looking at. I have seen communities in data science, for example, different data science containers, have a very different approach in managing their containers. So it is not just the container type, but the thinking behind it, the tolerance for vulnerabilities, the appetite for risk. Because if you think about these are publicly available containers. Are they meant to be shipped to production? Probably not. It's great that these containers exist for developers to come in and experiment and have fun and start with an easy starting point, right? But the way most communities look at these containers is that this is just a starting point, a playground. Just go play with it. That could be a ton of packages, and that will mean that lots of CVEs may exist. But the idea is that when you ship these to production, they should have there's very little tolerance for CVEs. So irregardless of what the container type is, if it is in production, there is very little appetite for risk. People want their containers to have zero vulnerabilities, especially the customers. But again, if a lot of people take these containers and push it to production, so I don't think it is just a matter of the type of container, but how it is being thought of in terms of use by the actual people who are producing them and the people who are consuming them. Any other questions? Yes.
How do you think container management platforms like Docker or Kubernetes can do a better job to encourage container security?
I think knowledge is power. I do think that automating this, as I mentioned at the very end, is very important. Humans can't get, like we are brilliant, but we can't basically, looking into how the complexity have risen in the last couple of years, it is very hard for a human, even if that person is a container expert, to wrap their head around these containers and fully understand what's going on. So automation and optimization is key. Yes?
Hi. Thank you. First of all, it was very informative. My first question is that the data that you shared, is that for, you said public cloud container?
Yes,
How about
publicly
private?
available containers.
So the vulnerabilities would be different for private cloud?
Oh, like actually, yes,
Okay.
yes, hopefully, yes.
Just wanted to, yeah, awesome. And you also mentioned about risk exception. So, and I know that it goes for firms' risk appetite statement and all that, but when there are so many vulnerabilities out there and the firms have options to accept risk, are there any data out there that the executives can look at and like the, you know, what's out there and what's the acceptable risk for the firm, like they can compare from that data?
After Log4Shell, as I said, 2022 has become the year of software supply chain security. What we're hearing from our customers is that customers have zero appetite for vulnerabilities anymore. In the past, it was like, no, we are going to go fast and break things and accept risk in the process. I'm not hearing it anymore. What I'm hearing from consumers is that sometimes, you know, this is not the most rational thing to do because that CVE, there's a lot of human in the loop type of things, right? That CVE, you go into the details of it, it looks critical, but it's not necessarily a true CVE. So people say, you know, there are these discussions. This CVE is not really a CVE, and the customer says, if it is not a true CVE, if it doesn't matter, why does it exist in my environment anyways? And governments, especially the US government in the last year, I think made it very clear with all those executive orders CVEs are not acceptable. What I'm saying is a little further, I guess, from that. What I'm saying is that the sheer CVE counts are not even representative of the full risk. So you might be sharing a container with zero vulnerabilities with your customers today, but if you had attack surface, all these packages with zero vulnerabilities that are redundant for your code, that's not okay. You need to ship the most optimized, the best-in-class container to your customers to make sure that there is zero risk.
Right, so the 3 remediation plans that you provided, the 3 bullet points, those are the main things we should be, you know, those are the items we should be used to remediate or look after for vulnerabilities, right? Those 3 steps.
I don't think my data showed any path to resolution, honestly. These CVEs lived in these systems forever. Mm-hmm. But yeah, if we were to do a better job in private containers in our own environment, I guess you need to look into those resolutions windows a lot closely.
Makes sense, thank you.
Thank you, great question. Any other questions? Oh, yes.
In your research, did you see any correlation between the release schedules that people had as far as if they release every month, those containers had less vulnerabilities than those that had more of a 6-month timeline for releasing new versions?
That's a great question. That was actually the hypothesis. And my hypothesis was that those ones that keep updating their packages would have a better trend line in general, the totals. But I mentioned something else. If you noticed, there was this Sankey diagram. A lot of the package maintainers said, we are not going to fix this issue, period. So a significant percent, almost 60% of non-resolved incidents were in this category. So the package updates didn't help at all because that was an accepted risk. That's CVE for one reason or the other. And so I didn't see that meaningful correlation, although I expected to see that. So great question, but it doesn't really, I couldn't be able to prove that in the data set.
Hi, I have a question. So I know that there's no general standard of slimming a container properly, right? you were kind of talking about the end-tail analysis at some point as one of the methodologies. But the question is, what if you have a common process that could be the vulnerability? Because that's, like, for example, Log4Shell. That was everywhere, and that was a very common process. So how can you apply the end-tail analysis in this case?
So there are different approaches to slimming, and at Slim.AI, we have our own technology looking into this. We observe a container during runtime and try to understand what's actually running, and everything that's redundant we think should be pulled out from the system. And with something like Log4Shell, right? So there will be cases, even with the slimmed container, I think there'll be CVEs that exists. And you need to, at that time, you need to be thinking about maybe alternative packages. Log4Shell, for example, after the crisis moment, they upgraded, but a lot of the people didn't really upgrade for various reasons because they were afraid to break their system. So after a year later, 40% of all downloads were still the risky versions, which is unbelievable, but it's the case. I think slimming doesn't really say that you are foolproof, there's nothing problematic in this container. But you know that your attack surface is minimal, it's optimized, and the CVEs, the packages in those containers need to be discussed carefully. So if there's an alternative package for that package that runs, that's essential for your container, you should definitely think about it. And maybe, in certain cases, you might want to write your own package. There's a lot of reuse in open source, but that doesn't really guarantee a risk-free environment for us. We're done. Thank you so much for your questions. I will be around, thank you. I'll be around answering questions, so feel free to come by and chat. Thank you.